Hi, it's Dr. Z. In this video, I will review correlation. By the end of this video, you'll be able to conduct a two-tailed hypothesis test with Pearson R correlation. Please print the corresponding handout for this video and feel free to pause the video at any time to take notes on the handout. We will continue to build on your foundation in hypothesis testing and introduce a new statistical test called correlation. In its most simplest form, a correlation is measuring the relationship between two variables. There are several different measures of correlation. For this video, we will focus on Pearson correlation. A hypothesis test with Pearson correlation will determine if the relationship between the two variables is statistically significant or not. This video will explain how researchers can do that. Well, what is a correlation? The prefix co refers to two things, and the word relation refers to relationship. When put together, a correlation is measuring and describing the relationship between two variables. As stated earlier, there are several different measures of correlation. The Pearson correlation measures the linear relationship between two variables. Thus, if we were to draw the relationship, it should resemble a line. In a previous video on correlation, you learned how to calculate a Pearson R correlation. Now, we will conduct a hypothesis test with it. This diagram illustrates the process of hypothesis testing. We will use the same 4 steps in conducting a hypothesis test with Pearson correlation, with some modifications along the way. Step 1, the yellow Lego, is to state hypothesis. This step will be modified because we're determining whether a correlation exists between two variables. The key word here is correlation. We will now replace the word difference with correlation. The null hypothesis will state that there will be no correlation. Because we're measuring correlation now, instead of population mean, or mu, the statistical notation will also change. And the notation for Pearson correlation is the letter R. And recall that if there's no relationship between the two variables, the Pearson R value will equal 0. Therefore, in notation, R equals 0. For the research hypothesis, we are predicting that there will be a correlation. And if there really is a relationship between the two variables, then R should not equal 0. The star here is to remind students that the wording and statistical notation will change for a hypothesis test with correlation. Step 2, the blue Lego, is to set the criteria to make a decision whether the study worked or not. This step has modifications because we're testing the relationship between two variables. First, we will set our significance level P as we did for previous hypothesis tests. Second, we'll have our first modification. We need to calculate degrees of freedom with a new formula. Recall that the typical formula for degrees of freedom is df equals n minus 1. Well, in a correlation we're comparing two variables, so now the new formula will subtract not by 1 but by 2. Third, we still need to find the critical region. However, the critical region is now an R value. And we need to use a new table called the R distribution table. The stars here are to remind students of these two modifications. Well, let's review what this new table looks like. The R distribution table is organized with a column for DF, columns for significance levels, and most importantly separated into one-tailed and two-tailed tests. There are common mistakes that students can make while reading this table. This is an example to practice reading the table. First, we will find the degrees of freedom. Second, we will find the significance level for a two-tailed test, which is different than from a one-tailed test, which is over here. Third, we will find the answer where these two columns meet. The critical region will be different for each hypothesis test because it is based on the sample size n. So step 3, the red Lego, is to collect data and calculate sample statistics. This step requires the calculation of the Pearson R correlation. Now, an important side note here. If we did not have the R distribution table for step 2, this step would actually require converting the R into a T statistic and then using the T distribution table to make a decision in step 4. The star here is to remind students that R was calculated in a previous video, so we do not need to review the process here. Finally, step 4, the green Lego, is making a decision about whether the study worked or not. Guess what? This step stays the same. In this test, we're using R instead. Now that we've reviewed the steps of hypothesis tests with Pearson correlation, are you ready to practice your new knowledge? I have one practice example for you to review. This is a short summary of the 4 steps that we described above. Please note that these steps are for a two-tailed hypothesis test with Pearson R. Modifications for this test are noted in bold. Please pause the video to write down these steps on the video handout. This lecture example wants to explore whether there's a relationship between sleep and mood. Since we really don't know what the relationship is between the two variables, we will conduct a two-tailed test with non-directional hypotheses. The details of this research study are also provided in your video handout. The sample of 5 students reported sleep and mood. The Pearson correlation for this example was calculated in an earlier video. I encourage you to pause the video here and try to do the 4 steps on your own first. Then resume the video to show the answers. Step 1. Since we are studying the correlation between sleep and mood, the hypotheses will include these variables. In notation, if there is no correlation, then R equals 0. The research hypothesis will reflect that there is a correlation. And in notation, if there is a relationship, then R should not equal 0. Step 2. As a researcher, we get to decide the significance level, and the preferred one is 0.05. In a hypothesis test with Pearson R, the first modification is to use a new formula for degrees of freedom. Using this new formula, the degrees of freedom is 3. Since we do not know what the relationship is between sleep and mood, we need to draw a critical region R for both tails, above and below the mean. The corresponding R scores for 0.05 significance level 2 tails is R equals plus or minus 0.878. The box indicates the final answer that I'll be looking for on problem sets and exams. Because the R table provides scores to 3 decimal places, you may keep the answer to 3 decimal places. Step 3. The Pearson correlation for this example was calculated in an earlier video, which resulted in an R of plus 0.95. The box indicates the final answer for this step. Step 4. Now we need to compare the sample R score that we calculated in step 3 to the prediction which we determined in step 2. In other words, does the R of plus 0.95 fall in the critical region R from step 2? Well, the answer is yes. Then the decision is to reject the null hypothesis. The box indicates the final answer that I'll be looking for on problem sets and exams. Now, more specifically, the strong positive correlation between sleep and mood is statistically significant. After a hypothesis test is conducted, the researcher must report and interpret the results of the study. Well, wait, we're not done yet. Remember that Chapter 6 introduced how effect size plays a role in statistical significance. We now need to measure the effect size for a Pearson correlation. Ironically, R itself is a measure of effect size. And since we've already calculated the Pearson R, we do not have to calculate anything. Please pause the video to write down these steps on the video handout. Now, let's briefly review effect size for this hypothesis test. First, we already calculated R in an earlier video. Therefore, we don't need to restate this R in the summary statement. However, we do need to determine whether the size of the effect is small, medium, or large. This verbal description of effect size will be used in the interpretation statement. Finally, let's practice those summary and interpretation statements. There is one item that will be new to the summary statement. First, since we're calculating a correlation now, and we do not have any sample means, we don't have to write the first sentence of a summary statement like we used to do for a t-test. Now we will only have one sentence for the summary statement. We will continue to report DF and use R instead. I encourage you to pause the video here and try to write the statements on your own first. Then resume the video to show the answers. The summary statement will now consist of only one sentence. This sentence will report the R score, degrees of freedom in a parentheses after R, significance level used, and the decision you made. Since R is a measure of effect size, we do not have to include it twice. So let's go to the interpretation statement, which will now consist of 3 sentences. The first 2 sentences will actually come from the initial interpretation that you determined after calculating the Pearson correlation in an earlier video. So the first sentence will explain the correlation. The second sentence will be even more specific and explain the relationship between the 2 variables. The third sentence will describe effect size. In summary, correlation involves measuring and describing the relationship between 2 variables. This relationship can be then tested using hypothesis tests to determine if the relationship is statistically significant or not. Learning how to conduct a hypothesis test with the Pearson R correlation is one more major Lego building block needed to understand statistics.